Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge third question, minimum operation to form subsequence with a target sum. Earlier it was tagged as the medium question, now it's the hard one because in reality it has to be in that manner only. So now let us go ahead with the reading part of this question, then about the constraint, and then we'll check out the examples which are given, and then finally the coding part for the same. So let us first read this question. So here, let me first zoom the screen so that it is clearly visible. A minute. Okay, so here we are given a zero index array num consisting of non-negative power of 2 and an integer target. In one operation, you must apply the following changes to the array. Choose any element of the array nums of I such that nums of I is basically greater than 1 because the least power which is there, that is 1. So that's why it should be greater than 1. Remove nums of I from the array. The nums of I which you had chosen, you are required to remove that and add 2 occurrences of nums of I divided by 2 to the end of that nums. So we are required to return minimum number of operations which we are required to perform so that nums contain a subsequence whose elements sum to the target. If it is impossible to obtain such subsequence, then return -1. And we know what is the subsequences. So basically, as per this thing which is mentioned, so this clearly states that the sum of all of this, if it is less than target, right, then at that moment we will be returning -1. So only this was the thing for this particular statement. Now let us check the whole question, that how exactly we are required to do this. So now comes the part, that first thing which they have mentioned. See, before that let us check for the constraints. So constraints are like in the power of 2, the nums of I can go up to 2 raised to power 30 and target can go up to 2 raised to power 31, and the length of the nums could be up to 1000 only. So as per these constraints, the question is required, we can easily go ahead with a solution where we can use these numbers in the form of bits as per the constraint. So this was one of the hint in this particular question. And now let us go ahead with these examples. So first example which is given to us, that is 1, 2 and 8, right? And the target is 7. So as we are required to solve this particular by using the bits, so see, it would be 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, that is up to 8. 8, 4, 2 and 1, right? So first thing is that we will be starting from this 2 raised to power 0, means basically here as we would be solving this question using the bits. So in that context we will be starting from I is equal to 0 and going till I is equal to 30. And why 30? Because it is clearly mentioned in this question that nums of I could be at last 2 raised to power 30. So now how the things would be. So here the thing is that as we are required to figure out if there is a subsequence which is equal to this, whose sum is equal to this target sum, then it's fine. We can directly return with the output as 0 because there we are not required to do any operation. But if that is not the case, then in that context, first we are going ahead with the first in this number line. So 1 is there. Now then we are required to go ahead another and add up this one, right? But 3 is still less than 7, right? But we are still having one more number there, that is 8, right? So the first thing would be we will be required to reach this 8, right? So for that purpose we will be moving ahead with one operation, and then after that we will be easily able to reach this 8. And then we got to this 8, and when we reach this 8, then what we are required to do is we will be simply dividing this, and after dividing that what we actually got was 1 plus 2 plus 4, right, which is completely equals to 7. And that's why just to move till this particular 8 we did one operation, and that is what we are returning here. Now let us check the second example. So in the second example, 1 minute. Okay, yeah, I can give here only. So in the second example, now the line would be like this: 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 3, 4 and 5. These would be the things here. Now the thing is that again, now we are given with 1 already, right, and again we are given with 1, so it would be 2 into 1 plus 2, which is also given to us, plus 2. So basically this we have reached, but it is still less than 12, right? But the thing is, to reach this 2 raised to power 5, we would be required to move ahead, and for that purpose we will be moving ahead plus 1, then plus 2 here. So till now these are the two operations which are being done till now. But the case here is, see, here this target is 12, right? So how 12 is made in the bits? So the thing is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2 and 2 raised to power 3. So for making it as 12, we are required to set this bit, that is 8 plus 4, right? And these two bits are unset. So that would be the case here as well. When we are having 2 raised to power 0 2 times, 2 raised to power 1 time, now just forget that it was 2 raised to power 1 2 times or whatever it was. When we are having count this, right, but this bit is not set in a target, right, then what we will be doing is we'll be propagating half the count of this to next one. So now its count become 1 plus 1, that is 2. So now the 2 would be 2 times present. Basically earlier case was, here we were having 2 into 1, right, so that would be 2, and now we are having 2. So when we add a one more 2 to the same, so it becomes 4, and that was all what we were getting here, right? So when we propagate it here, now its count become 2. Earlier its count was 2, now it is 0, right? Now the thing is that after this propagation is done, then the thing is that we need to check, does this bit is set in our target or not? But the case is that this bit is also not set in our target, right? So in that context, again, what we will be doing, we will be propagating this to the next by dividing it by 2. So now this 2 raised to power 2, it becomes 4. Already we know that till now we were having 4. So now this particular bit is set, right? We will be checking again that if its bit is set or not. If its bit is set, then what we will be doing, we will be utilizing this particular count. And now from the 12 we will be subtracting this 4, and now we will be left with 8. What happened? So we will be left with 8. So now the thing is that now we are required that how many steps we are required to move forward to reach this 32. So we were at this particular point, and now as we have already utilized this, so we will be moving ahead at this particular, that is now we are at 2 raised to power 3. So from 2 raised to power 3, that is 8. Now how many steps we are required to move to reach this 32? So this would be the first step, and this would be the second step. So this would be the case, and these are the two operations which is required, and that is what the answer is. Because the previous propagations which we were doing, that was already present in our array which was given to us. But what was required to actually gain, to go to reach that particular which was already present here, that is the thing is that if we divide 32 by 2, right, so it will reach 16. right? Then if we divide 16 by 2, then it will reach 8. And 8 was the required number, and we were at the 8, and 8 was not present in this particular array, right? So that's why we were moving ahead, and for the motion of this particular only, we were incrementing our operations. So that was the thing which we were doing here. So now let me explain this with the last example which is there. So here there is nothing which I can explain, because the point is that here the target is 35, and here if we add up 32 plus 1 plus 1, then it will be simply 34, right, which is already less than 35. So that's why here we will be returning -1. So these were the three cases being covered in these examples. Now comes the part that how we are required to code this question. So to avoid any sort of confusion, I've already kept the code here. So now first part is that we are taking one vector which is of size 31, and all bits are set to 0 at the starting. Now this is the sum which we will be checking at every point, not at basically at every point, and accordingly we will be checking that what exactly we were able to get. So here first thing is that we will be taking this particular I, basically till 0 to n, means whatever numbers are present in this particular nums, that all we will be checking. And then what we are doing here is, say in that example which we were discussing earlier, so here the thing is that here log 2 of x, basically here x is this, right? So log 2 of this one, that whatever it is, that we will be storing here, right? Then log 2 of 2, whatever we will be getting, that we will be storing here. And like that only we are having this count as 2 and this count as 1. Basically on this, the log 2 of 1 would be 0, then it would be 1, 2, and here the count would be 2, and here the count would be 1, then 3, 4, 5, this would be for 32, and that's why here the count would be 1. So this all we are storing here. This x basically represents the total sum which is there for this num, and we will be here only checking that if that total sum is less than target or it is equals to target. If it is less than target, then we will be directly returning -1. So now next part is that this particular thing was for the purpose of storing all the counts of those bits which are there, and for checking that is that sum less than target or not. Now this HK is already checked. Now comes the main part of this question. Now we will be starting from I is equal to 0 to 30. That is what we are going to do. So first thing is we will be checking if our bit is set or not. If it is not set, right? This is the case when the bit is not set. Then in that context, what we will be doing is we will be propagating our this bit's count to the next bit and incrementing the I. Then the same we will be doing again and again until we get to that particular I where it is set in the target as well. So then we will be checking if that particular is set. Then we will check that if C of I is greater than 0, that is, does it have any count or not? If it would be having count, then we will be decreasing that count. That is, now we have utilized that count. And why here we are not doing any operation? Because this was readily available in our array, and because of that only we were able to propagate it. Now if that C of I is not greater than 0, that is, we don't have any count in that. So in that case we will be doing our operations. So this is where we will be doing 32 by 2, then 16 by 2, and so on. So in this context, means in this else part, now the thing would be, first we will be checking until our I is less than 30 and C of I is equal to 0. Means basically the count of that is still 0, then in that context we will be moving ahead and incrementing our result, basically doing more operations. And if the case is that it is if it is not equals to 0, then in that context we will be decrementing our I. That is, now we have utilized this particular count, and then we will be continuing again with this particular, that would be the case. And then again we will be checking that whatever we have put there, is that really present, is that bit set in our target. If it is set, then it's fine. If it is not set, then again we will be going ahead with this particular while loop, and like that only we will be easily able to get that how many operations were exactly required in this particular question, and then we will be finally reaching this particular result. So now comes the part for the time complexity and the space complexity. So here we can see that here we are running the loop till order of till n. So that's why here the time complexity is order of n. Then here it is if condition, then this while loop which is there. Now here the while loop, it is of order of 30, and then inside it we are having this if condition, then else condition which is there. So here again the loop is order of 30. So basically it goes 30 into 30. So 900 times which is there. So basically the overall time complexity in that context becomes n plus 900. And here n was at max. Here n was n, which is basically the length, it was at max 1000. So this 900 is basically less than 1000 only. So that's why it was not able to reach till n square time complexity, still less than n square time complexity. So that's why in that context it is the time complexity is equals to order of n, and the space complexity becomes order of 31, because we are using a vector of size 31 here, which is again equals to order of 1 only, as this is constant. So this was all about this particular question. If you have still any doubt, you could comment that down, and I hope you like this solution. So if it was really helpful to you, so please do subscribe to my channel. And this was all. Thank you.